Okay, I was trucking right along with the video when I realized we had run out of time, so I'm going to resume where we were. So we just found ZT, and we were about to find IT. And IT is just simply a matter of taking the 16 volts and dividing it by the 1.686K for ZT. The ZT being impedance total. So if we divide 16 volts divided by, excuse me, 1.86, and of course our answer will be in milliamps because we're dividing by K, I get 8.60 milliamps. So let's see if what they got. Yep, 8.6. So we're spot on there. Now we also need I sub R, I sub C, and I sub T. Of course, we've already got IT one way, but it's wanting us to use the IT formula the other way, the square root of IR squared plus the square root of IC squared. So let's go ahead and do the IR. Of course, the IR, it's just a matter of adding these two resistors, dividing it into 16 volts. So let's do 16 divided by 2.6. And that gives us 6.15 milliamps. And that's what they got. And they went ahead and did the IC as well. So let's do that. It'll be 16 volts divided by the 2.65. And that gives us 6.03 with some rounding, 6.04. Now, to get IT the other way, we're essentially going to use this formula right here. And I'm going to draw it on your piece of paper here. And it is as follows. IT equals square root IR squared plus that should be IC squared. Let me undo those last couple to get that where you can read it, make it legible. Tried to sneak it in, but it didn't quite look. IC squared. So basically, we're going to take this value, square it, that value, square it, add them together, and get the square root of that. So I'm going to say 6.15 squared plus 6.04 squared equals, and get the square root of that, 8.61. So they got 8.62, and if we round that, we got 8.62 also. So we got the same result as they did, and it's just basically applying the formulas, applying the math, and we're done. So let's see what we've got next. And it says we may have some rounding. So if you rounded some of those off and did some different values, you may arrive at something close, but maybe not dead on. So let's move forward. All right, so now here's our next challenge. And again, we've got to take this through step by step. So let's go ahead and clear out our, well, we'll leave that little formula up there. It might come in handy. That formula will apply. Oh, I'm going to rewrite it. So let's get rid of some of these. And we'll kind of write them as we need to go along. Well, the very first thing we need to know is CT. Whoops, and I'm not sure how I did that, but let's fix it. All right, let's try that again. So we need to know CT. This looks like some nice white space. Let's use this color. So CT is pretty easy. It is just a matter of what? Adding those up, right? So let's use our calculator. So we have 0.44 plus 0.44 plus 0.44. 0.44 plus 0.44 plus 0.44 equals 1.32 microfarad. So let's write that down here. 1.32 microfarad. Now, we've got to get the X sub C for that to get the equivalent value of that, right? So let's do X sub C here. And it is 1 over 2 pi FC. So we got CT, and now we're working on our X of C. So let's do that math here. So 2 pi 6.28 times frequency 60 times 0.00000132. Now that decimal point that we have is here, 1.32 micros. We'd have to move it back 6 places. 1, 2, 3, 4, 5, 6. So that gives us farads. Equals, and we'll crud, we're in scientific mode, and I'm gonna have to change back to standard to be able to use this 1/x. That's okay. 6.28 times 60 times 0.123451132. Again, that implied decimal there. 1, 2, 3, 4, 5, 6. So that works. Equals 1. So X CT is, I'm going to write it right here. X CT is equal to 2.01 k ohms. Well, R T is easy. There's only one. It's 1K. So now to get our ZT, we're going to have to apply that formula that we had up here, or maybe it wasn't up there a minute ago. No, it wasn't. So we're going to have to apply this formula, and it's a pretty lengthy one, so hold your horses here. ZT is equal to RT times X of CT. That's a T, by the way, so I'm going to try to make that as T-ish looking as we can, over the square root, and I'm going to slide the calculator down just a hair so I can write up under that, so you can still see the calculator, but you can also read what's here as well. And that is going to be RT squared plus X of C squared. RT squared plus X sub C total squared. So this is the square root of all that. So that's going to make it, first thing I've got to do is multiply these two times one another. Well, that's pretty easy. We can do that. I can do that in my head. 2.01 times 1. I believe I've got that. That's 2.01. And since they're both K, and since this is K, and we're it's going to work itself out, so I'm just going to go base units. So R total is 1 times 1 is 1 squared, so let's write that under here. So if we square 1K, we get 1, plus, because 1 times 1 is 1. If we do X of CT, that's, 2.01 squared, 4.04. So let's write that down. 4.04, so that becomes 2.01 over the square root of 5.04. So we're going to add, do that math, clear my calculator. So we're going to say 5.04 square root, and we're going to divide, I'm going to put that in memory, so we're going to divide by 2.01 divided by memory equals 0.89. So ZT, if I calculated this right, and again it's easy to mess up if you're not careful, ZT is equal to 0.8, we might as well say 90, because if we round 90, let me undo that and make it pretty. There we go. So if we round up 0.90, okay, say, which is about 900 ohms, no matter how you slice it. So we've got a ZT of about 900 ohms. So it is wanting the I of R, the I of C, and I total. We can go ahead and do I total and get that out of the way. We can simply take 120 and we can divide it by 900. And that's about 133 milliamps if we move it. So we'll say 133. Whoops, this is I total. 133 milliamps. Now, we know each one of these is seeing a total of 120 volts. So to calculate current for the 1K, it's just a matter of taking 120 divided by 1,000 equals about 120 milliamps across the resistor. Again, that's just voltage divided by resistance. Now we've got a ZT for this. An X of CT for this, which is 2.01. So we're going to calculate that. So we're going to say 120 divided by 2.01 equals, so we come up with 59 milliamps. Now notice we can't add these two together, 59.7, and come up with our I total. And that's because we have to go back to this formula here, and I'm going to write it down for you. And this is just kind of a way of double checking ourselves that I total is equal to the square root of IR squared plus IC squared, or IC total squared, there, ICT squared. So we're going to take both of these, square each one of them, add them together, and then get the square root of that. So IR squared is easy, 1 squared is 1. So we'll save that for last since we know that. But we'll take the 2.01 and we'll square it, plus 1 equals, and we'll get the square root of that, 2.24. That didn't look right. Am I the only one that didn't think that looked right? Oh, we didn't do the current. I'm sorry. So let's try it again. I did the resistive values. No wonder. Again, got about 2 minutes, so we should be good. So we're going to take these individual values and square both of them, add them together. So let's do this. Let's clear memory. I like using my little memory. Let's do 120 squared, and we'll store that in memory. And we'll take 59.7 and we'll square it, plus what's in memory equals, and then we'll get square root of that. 134. So we got 133 one way, 134 the other. Pretty darn close. Let's see if we're right. There we go. Perfect. So we got that one done. We're about at the end of this video. We'll work one more problem when we get back. Then it's going to be you guys, up to you to work these problems. So stay tuned for the next video. It'll be much shorter because we're only going to do one. And after that, it's all up to you. You should be getting the hang of it by now. But if not, as always, let us know. We'll be glad to help you.